and you can download it from the quest.com. It's a company which manufactures that. So it's an interface, it's an application which allows you to connect to the database, and the graphical interface. Advisable because a lot of companies use Toad. They don't use the interface which we use. The reason why we didn't download and then don't use it, because we don't have time. Okay, simply a matter of time. Okay, because downloading, configuring it, fixing, it'll take time. Everything. So, but I encourage you to use at home. Okay, just download the connect to the same database and use it at home, because this gives you more possibilities. You see the object in the database, you see the whole interface, and then you can manipulate with objects much easier than from this one. Okay, this is basically for executing SQL statements, backing up, and that's it.
Is it same like MySQL?
It's actually the same for MySQL. Yeah, they have an interface for different databases and versions basically. It's exactly the same. Interface is exactly the same, but it's for Oracle. Okay, you have to download Toad for Oracle. Okay. Yeah, you download Toad for Oracle because we don't use for MySQL. Okay. Or if you like to play with MySQL database, no problem. You can download it, install it, but keep in mind that MySQL does not come with the sample data. Okay, so you have to populate, create the database tables, populate it, and play after that. Okay, so the Oracle version which we downloaded, it comes with the sample data. Okay.
Oracle 11G is okay to?
No, it's not for these exercises and not for learning, because it comes with a different sample data. It's completely different. Okay, completely different. It's done for different purposes. Okay. So you can download it, you can export from this 10G and import it there. You can try to do that, okay? But I never done that, okay? So most probably you could, but no need, okay? So, and for our purposes, difference between 10G and 11G is negligible, okay? So it doesn't make any sense to use 10G, to use 11G. The problem might arise when you're working on Windows 64-bit machines, on Windows 7. Then you have to install it in XP mode, and then you have to make sure that it's running as a 32-bit application, not 64. Because yeah, this 10G is not 64-bit application. Okay, but taking that into consideration, you'll figure out. Okay, it's possible to figure. Okay, so let's refresh our memory what we've done before. Essentially, we accomplished these exercises. Probably you look at this exercise and wonder how we did that, right? Trick is that you have to remember the template for the select statement. Essentially, you have to say select, and then you specify field names. Okay, I'm saying field names, or one name if you specify one field. And field names should be separated by comma. For example, we have a field name which is called employee ID. We have a field name which is called first name, and field name last name, salary, and so on, if we are talking about employees table. And then we have to specify keyword from, which allows us to specify the table which we are going to query. And then you have to write down the table name. Okay. In this case, in most of our exercises, we use employees table, but not always. Okay, sometimes we need to query other tables as well. Okay, so this is a template for doing most of the exercises. So we did that. Okay, we actually allow us to see. We extracted Armato's first name and last name. We find out who is the employee number 1, 2, 3. Found out people who work on a commission basis, who didn't work on commission basis. Remember the null values there. Louis Pop's salary, and so on, so on, so on. Okay. Now it's going to part 2. Okay. So it's a little bit more complicated, but I'm pretty sure that you can do that. We actually did Donald O'Connell, right? Did this phone number, and then. Actually, we haven't completed 9, 10, and 11, correct? To the best of my knowledge. Correct? Okay. So let's start from 9, if you have done 7 and 8.
Well, we did, I think
We did 9? 10 2? Okay. We did with shipping clerk 2? You remember that? Okay, so we skip the exercise. Which one, if you remember?
The number 10.
10? Yes. Okay. Let's do number 10 together then. Refreshing the memory. So, question is that this information is there in a database, but it's not in a single table. So we cannot simply query table saying, you know what, give me the address. So I have to look for tables where this information can be retrieved. So I'm looking for physical address of HR department. So let me start my database. Some page. HR. Okay, let's go and investigate the tables. Okay, I need to find out address of HR department. So first thing I have to look is just departments, right? Logically, something should be stored in a departments table. So I'm clicking on departments table and find out that departments table has following fields. Department ID, which does not tell me much. It contains information about the department name, which is actually very good, right? Because I need to query that. Manager ID, I don't need that. And location ID, which might be good. Okay. So let's look what data it contains. Okay. So let's look at the department 20, this one, which is marketing. And it has manager ID, complete uninteresting, but it contains location ID, which is 1800. Okay. This might lead to the right solution to the answer, might not. Okay, we have to investigate it. Okay, so but at least I know the location ID from departments. If I know department name or department ID, I can find out the location ID code. Okay, so said that, let's look for the codes. Next thing which might turn my attention is table locations. Okay, I go to the locations and then okay. Table locations contain following information: location ID, street address, postal code, city, state, province, and country ID. Essentially what it means here that if I know location ID, which is the primary key here in this table, location ID can uniquely identify the location, okay, of the department. In order to make to prove that, I go to the data, the actual data this table contains, and I make sure that location ID, just if I have location ID, like say 1200, I can find out that this department is located in Tokyo. Okay, so the key is here having the code for the location ID. Okay, location ID can be retrieved from departments table. Remember? Okay, so I go back to the departments and write a statement in departments for departments. So let's do that. I go and write this statement. I'm saying select location ID from, actually before going to location ID, I like to select everything. Okay, select star from departments. So where department name equals marketing, human resources. Let's execute this statement. It gives me a department ID, department name, manager ID, and location ID. Okay, so please observe that human resources, whatever is specified in single quotes, is case sensitive. It should be used exactly as it is in a database. Exact case, exact as is, with the space, with everything. The rest of the statement is case insensitive, but the value which you specify in single quotes is case sensitive. Okay, so human resources is listed in a database exactly like this, so you have to use exactly the same case. Same format. So it gives me the location ID 2400. So I'm marking that. I'm putting comments here to this statement, putting two dashes, dash, dash, oh sorry, dash, dash. It means that the rest of everything which comes after dash will be commented, ignored. I'm putting 2400. This is an indication that this statement, this one, is actually evaluated to 2400. Okay? But to be more exact, I have to select only location ID. I'm not interested in everything else, right? So that's what I'm saying. Select location ID from departments where department name equals human resources. This statement, if I run, will give me only one single number, 2400. Correct? So as such, I write this answer 2400 here as a comment. Two dashes effectively comments out everything which follows that. Okay? So next thing, I'm going to locations field, locations table. I'm saying select star from locations. Okay? So I'm executing this statement, and this statement gives me actually virtual representation of the table. It's basically results set which looks like a table. And you observe here that if I know location ID here, I mean in this table, I can easily find out the address. It's not a big deal. Okay? So definitely I can do that visually, but the point is to do it programmatically, because this table might be huge, will not allow you to do visual inspection. So that's what I'm saying. I'm saying select star from locations where location ID equals 2400. Correct? This 2400 I retrieved previously. So if I execute this statement, how many records should I expect?
1.
Or 0. Right? 0 or 1. If I specified value incorrectly, like 5000, I may not get anything, right? But maximum 1, minimum 0. 1 because location ID is a primary key. Okay? It should give you only one value if it exists. So if I execute this statement, indeed I get one answer here. Okay? I get the street address, postal code, city, and country ID. Okay? Make sense? Sorry?
Now we need to combine that?
Yeah, that's the whole point. Because if I do a lot of searches like this, I don't need these 2400 stored somewhere, right? Because it's not convenient. I don't need to write it down somewhere or put it there. So I like to eliminate that. And indeed, there is no necessity of doing it. So if we look and analyze these two statements more attentively, we'll realize that this 2400, which is specified here, right, is a result of the very first statement. Correct? So as such, I can basically copy this statement, copy it, and put instead of this 2400. Correct? Or not? Like this. Now, when I run this, I'll get an error because you cannot simply assign to the another statement. You have to put a parenthesis here saying this is a separate statement. Okay? So if I do that, then I'll get the same answer. Okay? So what it looks like, it's basically a nested select statement. It's not a join, nothing's complicated. It's basically nested statements. Does it make sense? So this is possible only if the statement which is in the parentheses evaluates to single value. For example, I'm selecting in the parentheses, I'm selecting location ID. See, I'm saying select location ID. If I, for example, substitute it with the star, which gives me all fields, this statement will fail, obviously, because I cannot put an equation sign here, equal sign, and then assign to the multiple values. It doesn't work. Okay? This statement inside the parentheses should evaluate only to one value, because we are putting equal sign here. If you expect several values, then you have to put in operator. Okay, so in operator accepts list or between one of these. Okay, in that case you are fine. But if in the case if you expect one single value, it should be one single value, then you can put equation sign. Make sense? So you get it executed, so and get the same answer or different one? No. Okay. Error. What is the error?
I got an abbreviation. Does it mean something for you?
The code, yeah.
Several commands not properly ended.
What's the code?
What do you mean?
It says aura 00.
Aura 00933.
Okay. So what you do, you go to the browser. Okay. Go to the Google.
Yeah, I'm already there.
Okay. So type here aura 001132.
933.
933. Okay.
You're right.
Yeah. Okay, that's okay. We'll fix that. Okay. It says error, right?
You're right.
So opening. Okay. This one. Okay. And here's the explanation what it is. Okay. With examples and how to fix it. Okay. There are tons of documentation available about each of the errors, and so you probably forgot the parentheses. You probably forgot some operators. And here's the statement. Look here, whatever you see on the screen. Here, and then make sure that you have exactly the same syntax. Make sense? Can we move forward? Yeah. Okay. So that's the answer for number 10. And feel free to create nested statements. They execute it faster. And you can do several levels of nesting. So no one prevents you from doing that. Okay. If you need to do 3 or 4 nestings, no problem. Okay. Definitely logic will be more complicated, not easier, more difficult to grasp, but nevertheless it works. It should work if it's correctly constructed. Okay, let's go back to the presentation. Next thing which we discussing is sorting. Okay, remember when we started with the databases, I told you that the data is stored in a database tables in not sorted form. Okay, there are 2 main reasons for that. First of all, technically it will be too difficult to implement. Database will be constantly busy keeping the records sorted. Second reason is that sorting has different meaning for different people. Some people will like records sorted by first name and last name. Some people like to be sorted by salary, right? Some people will like to be sorted by ID, okay? So we cannot satisfy everyone, okay? It's not possible. So we decided to store it as is, but it does not mean that when we retrieve data, we cannot sort the result. We can, okay? Before showing to the end user, we can sort it. And this sorting is done by these keywords, order by, and then we specify the fields which we are going to sort. For example, if we like to sort by first name, we specify first name, by last name, by salary, specify salary. And order by should be the very last statement. Very last keyword in a select statement. So here is an example of that. Select start from employees, order by first name descending. So you have 2 options here, what to specify sorting order. You have the ascending and descending. Ascending is default one, so if you don't specify the order, that will be assuming ascending. But if you like to sort it by in descending order, go ahead and use this ascending. Should be space here. Okay. So let's go ahead and let's do that. Let's go ahead and execute this statement and see what we'll get.
Then the result.
10 results, but they should be in a sorted format.
Sorry, what is sorted for? Or 200?
No, we have 107 employees, but now number of employees is not crucial. What crucial is that these records which you see should be sorted by first name. If you put a descending, that should be, say, going back from the alphabet. You should see W and Z at the beginning, and then going down to the A finally, okay, in that order. So let's do it together. Let's see what we'll get. 48. Okay. So, okay. So you expect to see something like this. So first come Winston, and then William, another William, and so on. And if you look at the whole result set, the last one will be people with those names start with A. Okay? So if you remove descending, then default order will be ascending order, which you see that the order now is reversed. We have Adam, Alana, Alberto, right? So it means that though the records are not stored in a database in this format or in the previous format, but we can sort the result set. Okay, we don't change that, we don't alter the database itself or database table. Records are there in the database exactly as they were before, but we're basically showing a different format. Okay, is sorted format. Okay, and this is achieved using this keyword order by. Okay, does it work?
Mm-hmm.
Should. Okay, so for example, if you like to print company's phone directory, you like to see the results in ordered form, right? Instead of just looking a whole catalog for finding the right person, you like it to be sorted, because finding person in a sorted list is much easier than finding in not sorted form. Yeah, welcome. Come in. Make sense?
Yep.
Okay. So this is more eye-pleasing. You can sort by several tables, by several fields at the same time. You can sort by first name, comma, last name. That's also possible, and by salary at the same time, no problem. Or you can sort in reverse level. For example, you can sort first name ascending order, last name descending. Okay, whatever way you like. Okay. Yeah, we have one spot here, and good luck in finding some spot there. Okay. Yeah, and one spot there. Okay. No more questions? Okay. So then you have to cooperate with someone else. Okay. Okay. No questions? Okay. Let's move forward. Now, what we are going to do now, we are going to, didn't we cover this? Apparently not. No, okay. Okay. That was a different class. We are going to cover new operators, which actually simplify life much to the great extent. So the operators are following: in, between, like, and is now. And let's start with the in. If I like to select employees who are working in several departments, I can use in operator and specify this department basically in a list. Okay. Alternative to that, or actually what happens behind the screen, this statement is transferred to another one which says select employee ID from employees where department ID equals 20, or department ID equals 60 or department ID equals 100. Okay, that's what happens behind the screen, and that would be it's your alternative here. But if we use in operator, we don't need to specify or operator or department completely. Constantly repeating that department ID equals department ID equals. So basically, syntax is simplified. That's what in operator does. It simplifies the syntax. Now, the values which you like to list, you basically separate them in comma and put in a parenthesis. There is a limitation in Oracle for the number of items you can list here. So the limit is 1,000. Okay, so you can maximum number of items in this list is 1,000. Okay, so that's the limit. But in most of the cases, that's more than enough. Okay, only few cases you need to actually use union operator to combine two different statements. But for in most cases, it's okay. So let's go ahead and execute that. And in this case, if you run this statement, employees who are working in these three departments, 20, 60, and 100, will be retrieved. All other employees will be skipped. Okay. It simplifies the syntax drastically. Sorry?
Employee ID number?
If you don't like employee IDs, you can select first name, comma, last name. It's, more eye-pleasing, but essentially it's not a big deal, okay? Works, okay? So get some list, maybe say 10, 15, 20 employees, whatever, okay? Working in this department. So if you have several values to specify, you should specify in. Okay, you cannot set equal because equal expects only one single value. So next operator is between, which is similar to in, except that it generates the range. Instead of defined values, for example 20, 60, and 100, it gives you range, and the range is specified in this following format. It says department ID between 20 and 80. Okay, so you specify the lower range and the upper limit of the range. Okay, so what happens here is that between operator will generate the list behind the scene, a list which contains 20, 21, 22, all the way to 80. Okay, so 20 and 80 are inclusive, so essentially it generates 61 values here, and then it runs this statement for each of these values. And employees who satisfy this condition, who are working in departments which are ranging between 20 and 80, they are retrieved. Okay, so go ahead and do that. See, in this case, you will get more employees than in the previous case. Works? Okay. If works, let's go to the next operator. It's actually an example of between, which is using date and times, not numeric values only. So because this operator can be used for other than numeric values as well. If we like to get employees who are hired between 98 and 2000, we can execute this statement. Select start from employees where date between 01 January 1998 and January 2001. So you'll get a list of employees who work for this hired within this 3-year interval. 2 years or 3 years? Yeah, 3 years interval. Okay. So I recall the story about the Starbucks. So Starbucks had a policy which they actually implemented between 2000 and 2006. So basically, they took all tips which customers left for employees to the company's account. Okay. Employees were not happy, and they started to sue Starbucks, and they won, actually. And Starbucks agreed to pay a lot of money just to settle the suit. But they had to find out whom they are going to compensate, right? And they had to run a statement which looks similar to this, because their database is definitely much bigger, and that information was scattered across several databases. But the essence was the same. They have to actually generate the range between 2000 and 2006, and it turned out they had approximately 100,000 employees they had to compensate, because turnover in a Starbucks is huge. Okay, people come and go, And yeah, within within these 6 years, they had say 100,000 employees. Actually, a huge number. But bottom line is they had to run a statement which looks similar to this one shown. Okay. Like operator is an interesting one and very useful one. Is used in the situations when you don't know people exact name. Okay, like remember we had the example of a key G, and I asked to retrieve key G salary or phone number, I don't remember exactly. And some people try to squeeze, modify the initial conditions just to get at least one record. That was not the point, because I would like exactly key G, okay? And the result was that we didn't find key G. That was okay, but let's assume we have some customer who comes to the front desk and say, you know what, I think I'm looking for key G, but I'm not sure about his last name, okay? I know that last name starts with a key and then a second letter is E, but I don't know what the rest is, okay? So still front desk assistant should be able to help with that person, right? Just make a fuzzy search, and that's what actually like operator allows us to do, okay? So like operator allows us to specify a value, not exact value, okay, just fuzzy value. And in order to do that, we have to reserve 2 characters, which is a % and underscore. These 2 characters play a special role for the like operator, specifically for like operator, nowhere else. So % stands for any number of characters, including 0. So 0 or more characters. Underscore stands for 1 character only. So what means here is that if I run this statement, which is shown here on the first line, and then I say first name like NAN, it means that the following people will be retrieved: Nancy, Nanette, Nana. Observe the case, okay? So basically all people who have the first letters of the name start with a capital N, followed by lowercase a, and then lowercase n. The rest is not essential. If we have a person whose name is NAN, none, okay, that person will also be retrieved because % stands for 0 or more characters. So NAN is okay. But this statement will not retrieve Nana and Nanette, so you see that the letters are the same, but the case is different. So actually this is a case sensitive. Remember, everything we put in a single quotes value is case sensitive. And the like operator is no exception from that rule. So essentially if we have people with Nana and Nanette, we have to write another statement, so or like something like this, okay? So let's do this exercise. Let's retrieve all people whose first name starts with DAV, okay? Yeah, Dave. DAV. What do you mean?
Without process symbol?
Without process. First name starts with DAV. It may follow by other letters, but at least DAV should. Okay? And we cannot use equation operator because we're looking for basically people whose first name starts. Okay? Okay, let's see if other people have some more luck than here. Yeah, 3 people should be found. Okay? Did you find? Oh, percentage sign. Percentage sign, as it's stated here, is for any sequence of characters, including 0. It means that if you're looking for DAV, which is followed by anything, including 0 characters, then you have to use %sign. But if you're looking for a specific 1 character, then you have to use underscore. So in this case, it doesn't make sense to use underscore unless you're looking for example, let's go and do that together. Okay, that's 53. Let's do it together. This is the statement, right? I'm saying select employee ID from employees where first name like DAV. In this case, wrong one. DAV. And if I execute this statement, let me fix the quotes first, because that might be, okay? You see that I got 3 values, 3 employee IDs, okay? Now, but let's see, I'm looking for person name for person whose name starts with the DAV, and that person name is 5 characters long.
You can use two different underscores?
Yeah, one after each other. That's okay. In this case, I get again three employees. But if I use DAV 4 characters, I think I will get nothing. Yeah, no data found.
No. Yeah.
Okay, because in this particular case, I'm looking for DAV followed by exactly 2 characters, not more than nor less. Okay, it might be most probably that will be David. Okay, but you have to be very specific. Underscore stands for exactly 1 character, not 0 characters, but 1 character. Percent sign is more fuzzier, I would say. It allows to specify any number of characters. Okay, so Oracle database and other databases as well allow you also to use regular expressions, regexes. So in a regexes, you have more flexibility than this one. In regexes, you can specify, like for example, you can follow, for example, like this. I'm looking for person name whose first name, I'm looking for person with the first name which the second letter is A, but first letter is not D and not V, okay? Which is followed by 3 specific, for example, L, M, or N, okay? In that combination. You can do very complex searches, and it is possible to do, okay? So with regular expressions, not with these operators, okay? So but we're not going there into deep because we're not in regex class now, okay? So but it is possible, okay, if you're interested in. Okay. So this might be very useful when validating, for example, first name and last name and basically data in a database. Because when you validate the data in a database, you have to make sure that the first name are listed in a title case and the last name in the title case. And you cannot do that with this like operator, okay? Because like or it will be a very complex statement, okay? But with the regular expression, it's very easy to do. You're basically saying, you know, I'm looking for a person's first name whose the first character in the name is not capitalized. And then immediately, if you have some person listed with the lowercase, you'll catch that, okay? Or if you're looking for email address, person email address, you realize that you cannot use this like operator because there are basically too many email addresses to catch up, right? So in that case, you can write a regular expression saying, you know what, this is the pattern of email address, and find me anything which does not match this pattern. So it means that you'll find the data which is incorrect email address in a database, which is very valid, okay? Sometimes you may find yourself in the position when you need to validate the data in a database, okay? In that case, you have to write a lot of select statements and validation statements, and the regex is definitely a big help, okay? Any questions? No? Okay. So that's about like operator. And the key G actually is a problem with the key G we can solve with the like operator. Okay, we can say key, K-E, actually key G, right? Last name is G. We can specify where last name like G-E and 2 letters and then 1 underscore. Okay, in that case, everything will be retrieved of people who are matching this pattern, G-E. Okay, so let's do that. And null operator were partially covered. Remember when we, oh no, we didn't cover that, right? It's null operator. Okay. So if we execute this statement, actually we covered, I remember that. Commission percentage, yeah. So bottom line is that database allows us to not specify values. If a column is constructed that way, if column is allowed, or field is allowed to skip the values, for example, is nullable, then when we enter data into that table, we can skip that value, specifying that value. For example, if you look at the table employees, let's do that together. I'm going back to the database browser and look at the tables, departments, employees. If you look at the employees table structure, this is basically the structure of employees table, you will see that nullable in some cases says yes. What it means is that if we enter the values, for example, if a new employee starts at the company, these values, for example, phone number, salary, and commission percentage, manager ID, and department ID can be skipped. Okay, so basically, database allows us to skip these values and not specify them. So if these values are skipped, don't assume that there are zeros or something else. This means that this value is simply not specified, or with other words, they are nulls. Okay, And nulls can be tested only using this operator is null, which is shown here, okay? Because the one example of that, finding out people who are working on a commission basis, which we did in previous class, okay? And then this statement may return correct answer, but if we reverse the logic to find out who working on a salary basis, not on commission basis, then we got the wrong answer. Remember, we expected 72 people, and suddenly we got 0, okay? Because we didn't encounter this null operator. That this basically, this value is not 0, but it's not specified, it's null. So if we corrected that using this operator not null, then it was no problem, okay? We found all employees. So don't forget about that when you creating queries, because if the field can be nullable, you may skip, all of a sudden you may skip some values there when querying the table. Or in our cases, we skipped actually all values, okay? We missed all values from table, okay? Said that, next group of functions which we are going to cover are called aggregate functions, also very important ones, because they allow to do mathematical operations based on directly on a database level. So what happens is that quite often we do need to perform some statistical analysis of the data, very basic statistical analysis. Like, for example, find out how many employees we have in the company, on average how much money people make in department 60, or average employee time, how long employee work in the company on average, or something like that, okay? So definitely, in order to answer these questions, I can retrieve whole database into my program, right? Just retrieve, just say select star from this table, and programmatically work up this data on my application. It's not very difficult to create, but nevertheless, I have to do that. So, but in this solution, first of all, I have to write an application, right? Create an application. Second is that every time I need some value, I have to transfer all data from the database over the network, basically loading the database and loading the network, right? And finally, in order to find out one small number, right? For example, average salary. It will be much nicer if we create some kind of application right on a database, within the database, which will do these simple tasks, very repeating tasks, because these tasks are pretty common. And if we ask database to do that, then this calculation will be done on a database level. Definitely we overload the database, but we don't overload the network. Okay, so that's the whole idea behind these aggregate functions. And aggregate functions are count, sum, average, max, and mean. And let's see how they work. So count produces number of records in which predicate is true. For example, if I execute this statement, select count star from employees, I will get a number of employees in the company. How many results should I expect?
107.
No? 1. Okay, because if we don't have any employee in the company, we'll get 0, right? But at least one number, right? If we have some employees, we'll get exactly that number. That's no doubt. Okay, it always returns one single number. This statement.
5.
Why?
No, 5.
In your case, because you have 5. I mean, all people left your company. Okay, only 5 people left. Okay. We have to take care of that. Okay, I have to look. It's very strange. Anyway, what happens is that the count operates on all fields here because we specify star, and then we can also specify the predicate. We can say select count from employees where department ID equals 60. In this case, we'll retrieve number of people working in a department 60. You should get 5 here. Okay. Now again, I'm counting across all fields here. You have to be very careful when you're specifying star or something else. So let's do that together. Let's execute this statement together. First one at least, 56. If I another department? Okay. So let's go and do this. Say execute this statement. I'm getting 107. Okay. No, sorry. That's the answer. Okay. Now, what if I count not across all fields, but I count specific field, which I called employee ID? This makes sense because employee ID cannot be null. If employee ID is specified, it means that we have an employee there, right? So let's do that. And we get the same answer, 107. But let's query against the manager ID. Okay? In this case, we get different answer. How come?
Because we have managers.
One manager left the company? No, the reason is that there is one record in an employees table where manager ID is not specified, basically null. And this select statement will skip that. Sorry, count will skip that. Because count will not count records where the value is null. It's skip. So that's why make sure you are counting on the right fields. Why you have to specify field name compared to the star all fields? Because if you specify all fields, it will take much longer. I mean, longer time if you have a huge database. I mean, that's a performance penalty you pay. If you're executing this statement against employee ID, you're counting basically one field across one field. So employee. So it makes sense, especially if this field is a primary key. Okay, it makes absolutely perfect sense because if you have primary key, definitely there is a record. Manager ID can be is nullable, salary can be nullable. So if you count across these fields, you may lose some records. Okay, so bottom line is. So this one executes and definitely gives a correct answer, 107. Any questions? No, all clear? Okay. Similarly, we can get number of employees in department 60 if we specify the predicate, but that's these are details. Okay. Again, executing this statement should give you how many results? One. Okay, it doesn't matter what. Aggregate functions. Now, next function is sum, which allows the sum generate the sum across that specific field, and the sum operates on numeric values only. For example, in this case, if I like to know how much company pays to their employees, this is the statement. How many results should I expect? One result. Number might be different depending who is running the query, but the result should be, I mean, number should be only one number. And this is the basically summation. It's pretty much like Excel spreadsheet. You get the sum of across a given column. And if you execute this statement, you'll get something 600,000, right? That's the amount of money company burns on the salary. If you like to know the average salary in specific department, this is the statement for that. You say select average salary from employees for department 60, where department ID equals 60. And then you'll get average salary for that department. Okay. So if you like to know who is the least compensated employee, actually get a value of least compensated employee. How many records we should expect here? One. Because if there is a salary, definitely there is a minimum salary, right? So that's what it is. Minimum salary, min salary from employees. Okay. Minimum and max, you can definitely get a maximum salary as well. Can operate on any fields. These two, average and sum, operates on the numeric values only. Okay. Let's go and execute some of these statements, if you haven't done so. Works? Okay. Let's move forward. That's what we already said. So if there are no questions, let's do this exercise. Yeah, apparently, yeah, that's, you'll get the corresponding value what you're looking for. Again, you should not try to squeeze everything in one statement. If you need to do run several statements, that's okay too. That's not our goal. If you can, that will be great, but if not, that's okay too. Now, question number one, I'm interested in a number of employees working outside of the US, right? So you may feel that we should query employees table because employees are listed there. If you like to get count or whatever, that eventually comes to the employees. But the employees table does not list countries, whatever. It lists only the departments. So it means that if you find departments which are located outside of the US, we'll get an answer, right? So in that case, I'm going to departments table, saying select star from departments. And if I execute that, I will get the following answer. I'm saying department name, department ID, which is also a foreign key in the employees table, remember? It also links to the location ID. So location ID is stored in the locations table, so I have to query the locations. I'm saying select star from locations. If I execute this, you will see that I'm getting the information about the locations, which is a location ID is a primary key here, and also getting country ID. Okay, so essentially it means that now if I go roll back to the, I have to find out the location IDs from this table based on this criteria, country ID. Go back to the departments, find out which departments are there, and then having that information at hand, go to the employees table. Basically a three-step process. So, but let's start from here, from locations. I'm interested in the locations which are outside of the US. I'm saying select start from locations where country ID is not US. Okay? So it gives me the list of department locations IDs, but I'm not interested in street address and postal code and cities. I'm interested specifically in location ID. So that's what I'm saying, select location ID from these locations. And here is the listing of location ID. The listing might be huge, but I'm getting only these results, so 10 results, okay? But that my list might be bigger, okay? So, okay, this statement gives me the location IDs basically, correct? This statement which is highlighted. Now, I have this list, I can generate the list at any time, but let's go now to the departments, okay? I have to say select star from departments where location ID, which operator should I use here? In, because I'm getting several items, right? Now in, and I don't have that list at hand, but I know how to generate that list, right? And this is list generated by this statement. So that's why I copy and paste it here, actually. Let's do it here together. In, and I specify this statement, nested select statement. Now if I run this statement, I should expect all the information about all departments which are located outside of the US. And here what I get. I get 4 departments here. Okay? Department 20, 40, 60, and 70. Okay? Now, there is no need to write it down on a piece of paper because this is a list. And you realize that I'm not interested in department name, manager ID, location ID. I'm exclusively interested in department ID. That's why I'm saying select star, and instead of star, I'm saying department ID. And if I run this statement, I will get a list of 4 departments. Okay? 20, 40, 80, and 70. Okay? Now, next thing I have to do is just I have to query employees table, employees who are working in these 4 departments. Again, there is no need to write it down. I can make it come back. I'm saying select count employee ID from employees where department ID again, which operator should I use? In, right? Because I get a list. And then I have to say select this one. So these 3 statements combined will give me an idea of 30, whatever I have, 38 employees. Okay? One single answer. 38 employees working outside of the US. And you see that I don't write intermediate results anywhere else. Okay? Just everything is done nested. So if you like to reverse engineering that statement, You start from the most nested statement, this one. The statement which is highlighted returns location IDs for departments, actually locations ID for country outside of the US. That's what is specified. Now, using these locations IDs, I query the department table, which is this statement, to find out which departments are located outside of the US. Okay? I get this, and finally, if I have that department IDs at hand, I can query the employees table, simply selecting count, because I'm interested in count, and then providing department ID in, and then this list. Okay? Everything done using nested statements, which simplifies the query and gives you a straightforward answer. Okay? Without having necessity of storing intermediate results anywhere. Okay? So question number 2 is which department employee work in is basically subquery of this. Okay, if you run this statement, you'll get that answer. Okay? This one. These are answered to question number 2. 20, 40, 80, and 70. That's it. Okay. Yeah. Get an error. Okay, coming. Which one?
For the first one, I used the reverse thing. It looks like not properly ended.
This could come not properly ended. So it means that you missed parentheses somewhere. Select ID from where country ID not equal to US, where you use twice where. It's not correct. Use where twice without parentheses.
Yeah?
Yeah, it's not exactly the statement which I have over there, right?
Yeah.
Select ID from locations where country ID not equal to US. That should be nested one. See, instead of being the first one, it should be the last one. Sorry? Works?
Finished.
Yeah, okay. Yeah, okay. Sure.
The manager, they need to map it to the employee.
Yeah, we'll have, yeah, that's one. No, you have to use a keyword which we haven't covered. That's the tricky one, okay? We'll come that. You have to use distinct. Unique or distinct. But use distinct because unique is going to be deprecated, okay? In Oracle at least. Okay, makes sense? No questions? Definitely questions because the nested statements look very complex, but in reality they are not, because each nested statement is a separate select one. So you can, for example, select this one and execute, and it will give you distinct answer. For example, location IDs which are located outside of the US. Okay. Said that, let's go back to the exercise and see how many employees work in the Bay Area. Okay. This is a tricky one. Because we don't have table Bay Area, we don't have location Bay Area. The closest statement which I can run, I mean, it definitely has some flaws. It's not a bulletproof one, but I can say select. Actually, I can reuse this one. I can make my judgment based on the phone number. That's my idea. And so select count employees from employees where phone number like. So what area code for Bay Area?
408.
408 %, right?
515.
Okay, we'll do that. or 415 or 650, right? Or what else we have? We have 9 to 5 or 510, right? Or 510 is actually East Bay. And 9 to 5 is also East Bay. I think, yeah, okay. 680, I believe. This is actually 408 code is split into two parts a month ago. So, yeah, okay, pretty much it, right? So, we wrote, say, 4 like statements here, or 5. And that will give more or less accurate answer about the employees working in the Bay Area. If I execute this one, it gives me 46 or 45 employees, okay, based on their phone numbers. And then you realize that this is not accurate because people may come from different areas and keeping their cell phone number and keeping them and so on. But assuming that the working number, I mean the office number, it more or less accurate. To be absolute accurate, then you have to query the zip codes which belong to the zip codes matching the Bay Area, and query the zip codes. Okay, a list of zip codes for a given area is freely available from postal office website. We can navigate, and then it probably can modify this database, create another table, areas by zip codes, whatever, and then query that table to be absolutely accurate. Okay, this is more or less. Okay. But that's as much as you can do from these tables. Okay. If you come up to different solution, no problem. Go ahead, suggest that. Any questions? No. Okay. So it means that sometimes you have to think. Okay, how to fish out information. Okay, it's not always like straightforward. Okay, we get this field from this table. That's it. Find out employees who don't report to a manager. Basically, that's we partially covered that. I'm saying select, start from employees, where manager ID is null. Assuming that if manager is not specified, that person does not report to manager. But company may have different policies as well. They may say, if manager ID is 9999, okay, it means that there is no manager. Okay, it might be that way as well. Okay, don't assume that it will be always null. Okay, you have to ask. Okay, if not sure, don't make assumptions. Just ask. So if you execute this statement, you'll get one person, Stephen King, who is a president. Definitely, he is not reporting to anyone, any manager at least, but he is reporting to stockholders. Okay, investors. Okay, we got that. Next question, next exercise is find out who's getting highest commission. Okay, this is a little bit tricky because first of all we have to find out what the highest commission is, the value of highest commission. Okay, and that will be select max commission percentage, right? PCT. From employees. Now this value is always single value. It might be 0, might be something else, but it's always one value. This is highest commission. Now I like to find out people who's getting that, so I'm saying select start from employees where commission PCT equals this one. And how many records should I expect to see here? No. At least one. But can we get more than one?
Yes.
Yes. If 2 people getting the highest commission, we'll get 2 people, right? So highest commission is always one number, but number of people getting that number might be different. So if I execute that, I'm getting this person, John Russell, who's getting that commission. Okay? and we can verify that this is 0.4 and this is the highest commission. In this case, I don't get intermediate results. I don't like to see what the highest commission is, but I'm pretty sure I'm getting that person is getting the highest commission in this case. So, which is this one. Okay, got it? Okay, next question is, who is employee number 1? Okay, so basically it's very close to highest commission. Let's see that. I'm saying, first of all, I have to find out employee number 1. I'm saying minimum hire date. Right? Hire date to start date, let's see. Yeah, it should be number of date. Yes, that's correct. Hire date. Yeah, that's probably it. Okay, so again, I have to use aggregate function min to find out the minimum date from the hire date, minimum hire date, and it turns out to be same person, Stephen King. Okay, he started on 17th of June, 87. This is absolute minimum date recorded in a company. So basically, he's employee number 1. Okay, again, I don't select value of minimum hire date because might not be the case. But is this correct answer or not? These exist, yeah, but yeah, that's actually you're thinking in the right direction. So according to SOX regulations, which was implemented not long ago, if employee leaves the company, that record should be kept at least for 7 years. Okay, so it means that if some employee leaves the company, this record should be transferred from employees table, because employees actually list the current employees now. But if the person leaves the company, this record should be placed in a different table, which is called probably job history or employment history or something like that, and it should be there. So employee may be the number 1 in a company, but if he is no longer with the company, he left the company, he still remains employee number 1, right? So it means that querying employees table might not get the final answer to that. It actually may give wrong answer, okay? If it turns out that that person is no longer with the company, okay? So it means that we have to query the other table as well. In our case, it will be, I assume it's a job history, but it depends, okay? We have to look what the job history stores. In order to do that, let's see what the job history table is, okay? I'm saying describe job history. Now, if I'm running this statement, I'm getting information about job history. It says yes, job role in which the employee worked in the past, okay? So essentially it end date, last day of employee in the job, in this job role, okay? This is a little bit tricky because if employee is promoted or demoted, he's still in the company, but the record is put into the job history table saying, you know what, this is the last day employee worked for the given role. But it does not mean employee left the company or employee actually get promotion or demotion, okay? So we have to be very careful. So we have to query that. Started is okay. Anyway, it means that don't assume that if you query and getting results from employee table, that's the final answer, okay, or correct answer. You have to look table job history or employment history or something like that, okay. Said that, let's move forward. how many people work in each department. We'll skip this advanced one. We'll do it after the last one. How many managers are in the company? Okay. So this is a little bit tricky because managers are also employees, right? And they are listed in the employees table. And if you like to query the manager field alone, you'll get value of 106. Okay. 106 as a manager, but that's not correct because the values are repeating there, repetitive values. For example, if I say select manager ID from employees, that will give me whatever. If I specify number of records as 200 and then run it again, you'll get, say, how many we get? We get 107 values here. Okay, so that's not good because you see that some values are repetitive here. Okay, so we like to get the number of unique employees. With other words, in order to do that, we have to provide saying select so count, right? Count first, and the count will give us gives us 106 because we don't encounter null. If a manager ID is null, we don't encounter him. So we're getting 106, but these are actually contains duplicates. So I have to say select unique manager ID. I'm saying distinct. This which we didn't cover that distinct, but if you run this, you'll get 18. Okay, these are 18 distinct managers. Okay, because managers cannot be existing several persons at the same time, right? Same manager. We cannot split that. So we have 18 managers in the company. Okay? Make sense? So there is also another keyword which is unique, which they are going to deprecate in the future. So use distinct. Okay? Compare with the unique. So, okay. If there are no questions, let's have a break, and we'll continue doing the last exercise. Last exercise, which is find out how many people work in each department. This is a little bit tricky because if we do it manually, we have to do kind of a two-step process. That's, for example, we have to scroll from top to the bottom of the table, find out how many departments are there, right? Create kind of a buckets, and then we have to scroll again just to get the employees, look at the department name and put in an appropriate bucket, and finally make a count, right? So kind of a two-step process. But select statement does not work as a two-pass process. It's one pass. You are allowed only to pass the table once, okay? So it means that even if you programmatically kind of find out the way, it doesn't work because select will be only one. So to fix this problem, we have to use special operator, special function, which is a group by. It says group by. Group by exactly does that. It basically passes the table, sees how many departments we have, created the buckets, and then started to populate these buckets. So the statement will look like this. Select count employee ID, because we're counting employee IDs, from count employee ID, and then departments, right? We said employee ID, comma, departments, right? And from employees, so group by departments. So this group by does exactly what it says. It basically creates a bucket or groups and populates this group. And we, in this case, we're saying group by departments. It will create buckets for each department. Department IDs. That's my error. Okay. By department ID. So, and here's the result of that statement. You see that we get department IDs, and we get the number of employees. So for example, in department 100, we have 6 employees, same number in department 30. We have 1 employee who's working in no department, department null. We have 3 people in 90, we have 2 people in 20, and so on, essentially. That's what we get, okay? This is using group by statement, okay? And thus getting answer to how many people work in each department. Okay. Okay, let's move forward. Any questions? No, okay. So let's move forward then. That's the explanation of grouping, what grouping is, and then the statement which we executed. Next thing which we can do is just getting first name and last of people who is getting top salary in each department. Definitely you have to group by departments, but first name and last name is kind of always not work in this statement. As that's what I'm saying. No answer provided. You have to figure out yourself, dig deeper, and probably Google it. Yeah, because group by is kind of a cumulative function. Okay, it actually group total sum of employees per department. First name and last name in this case are not, because you are looking for only one first name and last name per department who is getting the maximum salary. Okay, so you have to think about that. Next, which we're pretty much done with the select, so we are going to turn our attention to the next popular statements, which are insert, delete, and update. These 4 statements, select, insert, delete, and update, probably used in more, say, maybe 95% of all situations, okay? So basically the most popular statements in SQL language. So insert statement, as you may assume, is actually inserts new record into the table. And the syntax is following. Insert into table, you have to specify table name, and you have to specify values. For example, in this case, we're saying insert into employees values if we're adding new employees to the company. And then we have to specify values like 207, test, tested, and so on. These values actually, 207 goes into the employee ID, test goes to the first name, this is last name, this is his email ID, this is phone number, this is start date, this is his job title, this is salary, null is sorry, commission percentage, 103 is the manager ID, and 60 is the department ID. I have many classes, that's why I remember this, okay? But if you're looking at this statement, it's not obvious for you, okay? You have to find out how to correlate these values, whatever is specified, whatever are specified here, with the actual field names, okay? So fortunately, it's easy to do because this form of insert is a shortcut form. The long form actually lists the fields, like it's done this way.